Hello guys, welcome back. Today we're going to be talking about similar triangles. Okay, so how do we identify if two triangles are actually similar? Well, our first clue, or first way that we can identify it is through angle-angle similarity. Angle-angle similarity basically means that they have two or more angles that are congruent, right? Okay, so in this example, they give you 61, it's congruent. But also, H, like this angle, this spot H here, so angle GHF is equal to angle THS because they're opposite angles. If you guys go back to our grade 9 lesson that talks about angle properties, you guys know this. Opposite angles, they're the same. Alright, so 61s are the same and this one is the same, therefore they are similar triangles, right? And they meet this angle-angle similarity. Let's try another example. All these triangles similar, okay? Angle similarity, same thing. So let's examine. First of all, see that they share. Let's split this into two triangles first. Okay. You see triangle FSR and triangle FDE, right? They both share angle F. So we know that angle EFD is the same as angle SFR. That's our first angle. Also, these are the same because they are corresponding angles, right? Because these two are assuming they're parallel, right? You just assume they're parallel. So if they're parallel, then these are the same, and these are also the same. Okay. Please go back to our angle properties lesson. That's very important. You should know them, right? The Z pattern, remember, C pattern, F pattern, all of that, right? Please come back to those lessons. So here they're corresponding. So therefore, we know that angle FSR is also equal to angle FDE. Okay. So two angles that are the same, therefore they are similar. Okay. Our next property is side-to-side similarity. In order for triangles to be similar, they can either be angle-to-angle similarity or they can be side-to-side similarity, SSS. Okay. So side-to-side similarity basically means that the sides have the same ratio. What this means is that, let's say we want to take the side HG, right? HG. And let's take another one. Let's take HF. And we want on this triangle here, we want to take AB and AC, right? Because they're similar. They're the similar sides, right? Like whenever you're doing these side-to-side similarity, you have to choose sides that appear similar because obviously they don't give you the angles, so you don't know for sure if they're actually the same side or not. But in order, you have to pick the similar side because these two are both slanted, so I picked these two, and these two look like legs, so pick these two, right? So it's more side-to-side similarity is more like appearance-wise, like they're similar sides that are labeled, and then you check the ratios, and then you know they're similar. Okay. So first thing you have to know is that side-to-side similarity means that what this means is that HG over AB is equal to HF over AC. That's what it means, right? So yeah, that's literally what it means. So as long as you have the same the ratio between the say small triangle to big triangle, right? the ratio of the smaller one to the bigger triangle is the same thing to all the sides. That means that they're similar. All right, or it could be the other, or the fraction could be flipped around, AC over HF and AB over HG, doesn't matter. Okay, so okay, you test that they're similar. To test it, basically say HG is going to be, what is that, 12 over AB, which is that, and AC, which is 84, no, HF is 14 over 84. To test if they're similar triangles, have the same ratio, so 1 over 6 here, and 1 over 6. Okay, side to side similarity. That's what it means, right? You could have picked GF and CB, right? So just pick two sides, like two sides from each triangle, and make sure that each pair of sides look very similar to its counterpart on the other. This tells us to find the missing side given the triangles are similar. Okay, so first of all, let's identify the similar triangles. It's going to be SUT here and UBC. There you go. Okay, so similar triangles again. Let me just just repeat this real quick. Okay, they mean that the sides are extended by the same ratio, which means that the ratios between the ratios of the sides of the small triangle to the large triangle is the same throughout all sides. So let's see. The ratio between CU and TU would be the same thing as the ratio of BU over SU. Okay. All right. And we can find BU as x, and then we can subtract x from 12, x from 12, and get your unknown angle. Okay, so CU is gonna be 6, and TU is gonna be 16 plus 24, and BU is going to be your unknown, and your SU is gonna be 12. Okay, so let's just cross multiply everything. 6 times 12 divided by 24 gives you 3. So because x is 3, we got SB is equal to 12 minus 3, which is 9. Okay, so cheerleaders at the city high make their own megaphones by cutting off the small end of a cone made of heavy paper. If the small end of the megaphone is to have a radius of 2.5 centimeters, what would be the height of the cone that is cut off? Okay, so it gives the diagram here, right? Labeled correctly. Okay, so we're basically finding what's the height of this. Okay, so let's just draw this out as triangles. So we know that half of the 56 is going to be 28. Right, because we don't want this whole cylinder. We don't want this whole triangle. You only want half of it because it gives you radius, right? So you want half of it. Okay. So what you want to do is just draw one triangle. That's gonna be your big triangle. Okay. Actually, you don't have to. You can just use this diagram actually. Okay. And then the small triangles inside, like that. Boom. Nice. 28, 60. Boom. Okay. So these are, first of all, we have to prove it's similar. So so that angle is similar. So we can call that angle A. Actually, we can just call labels A, B, C, D, E. Okay. So we know that angle. They share the same angle A, right? These two triangles, they both overlap on A. They share the same angle A. So we can say that BAC is equal to EAD. Alright, that's our first similarity, and they also have the same right angle triangle. Boom. Alright, they both lie on the same flat plane, therefore they have the same right angle triangle. So we can also say that ADE is equal to ACB. Therefore, they are similar. After establishing they're similar, now we can actually go solve it. Using the side-to-side similarity theorem, say that we pick the two sides. So let's pick AC, right? Because it's a given, 60 AC. So AC, and we want the radius is also given. So AC, AD, radius is ED, and also BC. Okay. Boom. So we know that ED over BC is going to be equal to it's going to be equal to AD, which is the height. What we need. AD over AC. Now let's plug the numbers in. So that's going to be 2.5 over 28 equals AD over 60. Okay. So now we just find AD, right? 2.5 times 60 divided by 28, which is around 5.36 centimeters. Alright, that's your height. Boom, that's the whole lesson. Pretty easy. So I hope you guys understood it. And if you guys don't understand it, or you guys have any problems or any issues, please just go onto the Discord server or leave a thread. Other students will reply, and I will reply too. Thank you.